Okay, let's look at electrical energy. So earlier we talked about potential difference where there's 2 points in the circuit and there's charge moving past it and it's converting its electrical potential energy into other forms like the one that passed through the lamp, converting into heat and also the light. Okay, so basically the electrical energy is the electrical potential energy. And if you have a quantity of Q passing through it, for example the lamp and the motor, with the potential difference supplied by the battery, so the energy that is transferred to that lamp or motor will be given by E equals to VQ, and because Q equals to IT, so we can change it into VIT. So let's say we are doing an experiment that we wanted to get the electrical energy converted or carried by this charge of electrical potential energy. So what we can do is that, for example, we have a circuit here that the battery is 3 volt, and we have a lamp here that give out some light and also heat together with that. So what we can do is we can connect a voltmeter. Okay, we can connect a voltmeter across the lamp because we want to find the potential difference across that, and also we can connect an ammeter in series with this circuit. All right, so you get some value of the current and also a value of the potential difference, and then you time for a certain duration, let's say 1 minute, which is 60 seconds. Then you multiply by the value of the voltage and also value of the current, then you get the electrical potential energy. So next we have the quantity called the electrical power, and just like when we learned it in the topic of the work, energy and power, it is the energy transfer per unit time. So we have the E divided by time, and because E equals to VIT, I've seen it earlier, so we'll get it as VI or IV. Okay, so electrical power is a more common quantities that's labeled on electronic components or devices. So let's say I have a kettle here. Okay, so this kettle will have a label to tell us the energy that it deliver per unit time. So usually as at the bottom here, that you get some label, or at the side of the fridge or something like that. Okay, you can try to look at your devices or the electrical appliances at home. So let me show this value to you now. Okay, I've placed it in the back camera, and you can see from the label here that we got the power 250 to 300 watt. Okay, so that actually depends on the voltage and also the frequency, but generally it's about 250 to 300 watt. Then you know that it's like delivering 250 joule per second. Okay, so the energy that we are talking about here, that delivered by the electrical circuit, can include the heat, like for example the kettle and the lamp is light, and then if you have speaker, then it's sound. If motor, then it's mechanical energy, or it can be chemical transformation or any other forms of energy that is converted from the electrical potential energy. Okay, so we have an equation of P equals IV here. Can you derive another two variants of formula for the power? That would require the equation of resistance R equals to V over I according to the Ohm's law. Ohm's law, we'll look at it later, but just R equals to V over I, that you can derive another two variants of that. You can pause the video before I show you the answer. Okay, so as I mentioned just now, you can use the R equals to V over I, that we have V equals to IR, so we sub inside the into the V here, we get I square R as the second variance, And also if you have I equals to V over R and you sub inside this equation here, you get V square over R. So there are three equations: P equals to IV, P equals to I square R, and P equals to V square over R. So let's move on to the example of questions there. We have a 1500 watt of kettle, operate from 230 volts of the mains. Mains means your house voltage that is supplied to your house. Okay, calculate the resistance of the heating element. So we have P equals to V square over R, more convenient because we don't need the current, and therefore we have I equals to V square over P, and 230 square divided by 1500, get 35.3 ohm. Okay, so that's all for this topic. See you in the next video.